Okay, today we're going to do rational expressions. I think it's chapter 6 in your book, but I'm not terribly sure, so please forgive me. Okay, so the first thing we need to learn in chapter 6 is find the values that make the expression undefined. So what makes something undefined anyway? Technically, if we have 0 over the top, right? That means that we could have, if we have 0 over x, that pretty much equals to 0. But let's say we had x over 0. Well, anytime 0 is at the bottom, it is undefined, right? So you know all of that bit of information, but now we've got to deal with rational expressions. And rational expressions is just pretty much fractions. So, first things first. If I have p squared minus 18p plus 81 all over p plus 9. And I define the values that make the expression undefined, or the excluded values, depending upon what book we're using. We take the denominator. That's all we need to look at. And we set that equal to 0. So p plus 9 equals to 0, and we solve for p. So that's subtract the 9 from both sides, and p equals to negative 9. So how do you check yourself? Well, you plug it back in. So all of that riffraff at the top, and negative 9 plus 9, well, negative 9 plus 9 gives me 0 at the bottom, and anytime we have a 0 in our denominator, that makes it undefined. So let's carry on. Give you some more examples, because they won't always be just that easy. Let's say, I have x squared plus x minus 72 all over, let's keep it easy, 10x minus 10. Well, it's not going to be, well, we could do it that same way. So we take 10x minus 10, set that equal to 0, add the 10 to both sides, right? 10x equals to 10, divide by 10, and x equals to 1. So of course, if we check that and plug it back in, that'll be 10 times 1 minus 10, which will give me 0 at the bottom. So the values that we exclude, or that we are talking about that makes it undefined, will be the numbers, or these variables that we find. Okay? But let's add a little factoring into it, shall we? So let's hypothetically say I have 2x cubed plus 10x squared minus 12x all over x squared minus 8x plus 12. Now, again, we are only looking at our denominators, correct? So I have to factor this. In factoring this, I have to look and see what multiplies to be 12, right? Well, let's write out what multiplies to be positive 12. We have 2 and 6. We have negative 2 and 6. And then we also have negative 3 and 4. And positive 3 and 4. So out of all of these, which one of these sums add up to be, we need to get negative 8. Well, this will give us positive 8. This will give us negative 8. Aha, I think I found our answer. So this is the one that we will need to use. So we split that apart, and now my factoring becomes x minus 2 times x minus 6. So this is what this factors to be, or comes from. So since we're still finding the values for which makes the expression undefined, I need to set these equal to 0. So x minus 2 equals to 0, and x minus 6 equals to 0. Well, all I do is add the 2 to both sides, and x would equal to 2, And here all I would do is add the 6 to both sides, and x would equal to 6. So I actually will plug both of these values back in, and I guarantee that they will make the denominator equal to 0. So that's our first step. Now our second portion in the section is simplifying. Rational expressions. So let's simplify a rational expression for you, shall we? Let's start easy. If I had 15n over 30n cubed, right? Well, what multiplies to be 15? 5 times 3 and the n, and what multiplies to be 30? I would say 5 times 6 and 1n, 2n, and 3n. So I can cancel out my 5's, right? Can I reduce that a little bit more, I guess? Surely I can. 3 can go into 6 how many times? 2 times. And then I can cancel out an n. Now, even though I'm saying canceling out, there's technically a 1 up here, right? So my answer really would be 1 over 2n if we simplify that rational expression. Let's get into more detail here. Let's say I have x minus 4 over 3x squared minus 12x. Well, if I want to simplify the expression, I need to factor this. So this would be x minus 4 in our numerator, and here I realize I can factor out a 3 and a x. So this gives me 3x on the outside, and then I'm left with x minus 4. Again, anytime that you have the top and the bottom the same, we can cancel out, but that does not mean I totally get rid of it. So I cancel this out. That technically means I have a 1 at the top, and then I have 3x in the denominator, excuse me. Okay, let's see. Let's step our game up just a tad bit more. Give you one more before a new video. I have x squared plus 8x plus 12 over, or divided by, x squared plus 3x minus 18. Well, now in this case I have to factor the top and the bottom. So when we are going to factor, let's look at this first one here. So I need to see what multiplies to be 12, and we actually just did that and adds up to be 8. Well, we already know that if it multiplies to be 12, it could be 6 to 2 or 3 and 4. Which one would add up to be 8? It would be this one. So in my numerator, I would have x plus 6 and x plus 2. In my denominator, I'm looking at, well, what will multiply to be negative 18? Well, negative 18 would be either 9 and 2, negative 2 and 9, negative 6 and 3, or positive 3 and negative 6. Oops, did that backwards. Negative 3 and positive 6. So out of all of these, which one would add up to be a positive 3? Well, this one right here. So on my denominator here, I would have x plus 6 times x minus 3. Again, whenever you have a top and the bottom of the same factors, you can cancel those out. So x plus 6 cancels out, and here I am standing by myself with x plus 2 over x minus 3. And that concludes our first video, and I'll have another one for you in a second.